here. Okay, next is here, what is DH group? DH group allow two parties to share a secret key over an insecure channel. It is essential that key should be kept secret. Okay, now why we use Diffie-Hellman group here? Okay, now look here, we have two branches here, branch 1 and branch 2, and they are connected with ISP. Okay, now what we have to do when they will authenticate to each other? I told you we can use two things here. First pre-shared key and second thing is here shared. So when we are sending key, suppose here we are using key Shiva. If we will send the key and that will go in plain text, any attacker can capture it and they can try to spoof our tunnel. So what happened here? We use a protocol. Okay, first of all, what happened? The key will be protected by here using the DH protocol or DH group. Here the key will be offered to DH group and then DH group will encrypt it. And now what we will do, this encrypted format will go, instead of plain text information, then it will go to the branch 2. Okay, now what information received here? This encrypted material. Now same DH group will be used here. Okay, now when we will put the data in same, then we will get the key here. Okay, same. So here we can see the Diffie-Hellman group is used to exchange our key over insecure medium. What is our insecure medium? Yes, all the communication is happen through the ISP. So we want when the communication will happen through ISP and our attribute exchange, so key should be secure and that is protected by Diffie-Hellman group. And there are many group. If we are using 12 if you are using iOS version 12.4, then it supports 1 to 5. But if you are using 15.0 and later, then it offered a lot of groups. Okay, next is here security parameter index. Now question is, now we are talking about from a long time that what is SPI, what is SPI. Actually, what is SPI? To understand it, here what we have to do, suppose we have here branch 1 and branch 2, then all policies, and here all policy, what happened, they will, all policies will be here, what, hash. Same thing will happen here, all policies will be here hash, and it will get a number. For example, this one. So this value is called here ICV, integrity check value. ICV, integrity check value. When they will communicate, okay, when branch 1 will send the packet, branch 1 is sending a packet, okay, then it will send over as, okay, when they will initiate the session, sorry, let me clear it. Okay, branch 1 will put in all policy in a hash algorithm, it will get a, okay, both device create a hash of security policies database, that is called SPI. Now branch 1 and branch 2 both are creating, yes, its SPI is dollar rupees and dollar rupees rupees. Okay, now what we have to do here, when, okay, when they will initiate the session, okay, branch 1 will tell my SPI is this one, and when this will negotiate, it will tell, okay, my SPI is, okay. Now what happened, when branch 2 will send the packet, okay, this is the packet, and it will send its SPI. What its SPI? Yes, this is its SPI. When it will go to there, yes, what is the branch 2 SPI is this one. Yes, the packet is coming with this IP, this SPI. Yes, it's okay. When branch 2 will send the packet, okay, it is sending the packet. Yes, this packet is going from branch 1 to, okay, packet is going, then it will add own SPI. What its SPI? Yes, this one. Its SPI is this one. This SPI will, or packet will offer to with this SPI. Okay, branch 1 will check. Okay, packet is coming to branch 2. Okay, I will receive the packet. What is the SPI? Yes, SPI, sorry, SPI is matching. Yes, then I will accept it. Okay, now packet will be accept here. So SPI is travel with every packet. Okay, encryption algorithm. Encryption is simply a mathematical algorithm. A key is applied to data to make the content unreadable to everyone except those who have ability to decrypt it. Encryption algorithms are two types, symmetric and asymmetric encryption. Okay, now we want to know what is symmetric encryption. Yes, symmetric encryption algorithms are also called secret key cryptography, as the name implies that there is a single key, secret key, that is used to encrypt or decrypt data. Examples are dash, triple dash, and AES. Okay, again, symmetric algorithms are dash, triple dash, and AES. Next is DES, data encryption standard. It is a 56-bit keys has been broken. Okay, but here if you will read the documentations, they says that they can be broken less than 24 hours using modern computers. Next one is triple dash, three different 56 keys. First dash to encrypt, second dash to decrypt, and third one is dash to decrypt to create the ciphertext. And it has not yet been broken, but they have some theoretical flaws. Okay, AES, Advanced Encryption Standard. Yes, it is considered the most secure one, and it is available in 128 bits to 256. Next one is asymmetric algorithms. In asymmetric algorithm, one key is used to encrypt data, another key is used to decrypt the data. They are called public or private. They can be used vice versa, encrypt or decrypt, decrypt or encrypt. Now, asymmetric algorithms types digital certificates and RSA signatures. Okay, PKI, public key infrastructure, provides a framework for managing the security attributes between two VPN peers who are engaged in a secure communications. PKI consists a number of elements which are also called network entities. If you want to know how they work, okay, if you want to know the PKI message format, okay, host will generate a signature, RSA signature, and request for public key to the CA. Then second step, CA will send its public key, host will generate a certificate request, and that will send to the CA will sign with it its private key, and it will send the certificate to the host will save it, and this certificate will be used for communication. Again, I am repeating, first host will generate a RSA signature, and it will request for the pub key of the server. Then second step, server will send its pub key. Third step, host will generate a certificate request, and it will send it to the CA for signing. Next step is here, CA will sign with it private key, and it will send the certificate to the host will save it, and it will use for secure communication. Pre-shared key, in pre-shared key a single key is applied on both peers. Okay, now authentication header. Yes, it doesn't provides confidentiality because it doesn't use encryption. If you want to understand we have to go through a diagram. Please have patience. Okay, we know that IPsec features first confidentiality, integrity, data origin authentication, and anti-replay. If we are talking about here AH, and next one is here ESP. So first thing, AH doesn't provides confidentiality. It provides integrity, data origin authentication, and anti-replay. But if we'll talk about ESP, it provides all. So there is no way, there is no need that we will use here because we want all. So who will provides all? ESP is providing all, so definitely we will use here ESP. Next is if we will talk about that use IP protocol number 51. Okay, it doesn't work with net. Doesn't work with net, and it doesn't use net. It doesn't it does include external IP for ICV. It doesn't include TTL value for ICV. Now these things, 4 points: it doesn't work with net, it doesn't use net, it does include external IP for ICV, it doesn't include TTL value for ICV. So these things are not understandable. To understand them, we required a clean diagram. Please have patience here. Okay, we have branch 1, and we also have branch 2, and here we are connecting with ISP. Okay, we are connected to each other via ISP. Okay, A, B, public IP, C, D, private IP. Okay, when we want to communicate, then what happened? Remember it, this is public domain. Okay, when the data will communicate, when we are talking about here AH, if you want, I can type here number, for example, branch 1, branch 2, and ISP. Okay, okay, it's IP 101.0, or we can say incomplete 192.168.101.0, 192.168.102.0. Its public IP address 101.1.100, 101.1.1.1, 102.1.1.1, and 102.1.1.100. Okay, now this lane want to communicate with this one. If we will send the packet directly, ISP will drop it because that is private. So what happened here, we will create a packet. In packet I am typing short 101 will be source, destination will be 102. Here we will use a key. For example, we are using Shiva. Okay, and here it will also contain external IP. If we are talking about external IP, source will, our public destination will be this one. So here 101.1.1.100, destination will be 102.1.100. Okay, if we are talking about AH, then all thing will be hash, key, data, and external IP. Okay, hash. Then it will get a hash product. Same thing here. When it will generate a packet, this data will place here. Then it will add here a h header. And what is the result of h? Yes, this is the hash value. And then this external IP will be attached here. External IP. This format will be generated via branch 1 router, and this will offer to ISP. What ISP will check? ISP will check external IP, and what is the destination here? 102. It will forward it to the branch 2. Then what will do? Branch 2 will separate all things. Branch 2, yes, this was our data. Okay, branch 2 will separate data. It will separate, okay, ah contain integrity value and external IP. It will also contain key, which was implemented by us at the time of session implementation. Okay, same thing it will do. It will add key, it will add data, and it will add external IP. Same, it will get a hash value. If nothing has been changed, if there is no change, then sender hash or responder hash will be matched. If hash match, then it will be accepted, otherwise it will be dropped here. So here we can see, if we are talking about AH include all things. It will add key, it will add packet, and it will add external IP. All things are used for ICV, means integrity check value. So here we can see here, okay, it does include external IP. You can see here external IP is included for here ICP. ICV, integrity check value, but it doesn't include TTL value. Okay, look here, when we talk about TTL, by default TTL value is 255. Okay, okay, now when we will add TTL value here, at the time of calculation TTL value is 255, but when this ISP will forward the packet, it will -1 at the where at the time of verification, for example, TTL value will be 254. So if we will include TTL value, hash will never match here, because TTL value will be definitely change. It will when they will hash TTL value 255. If we have only one router in the ISP, for example, then TTL value will be 254. So TTL value will always change here. Then what we have to do here? Yes, if that the TTL value will be changed, hash value will be changed, will be changed, then it will always drop. So what it will do, when the will encrypt or it will hash, then what it will do, it will minus TTL from the IP header. When it will hash, okay, it will separate the TTL value. When it will dehash or it will verify, same, the responder will also remove the TTL value. So here we can say that it doesn't include TTL value for ICB. If we will has TTL value, then it will never work. Okay, next one is here, it doesn't work with net. Okay, as I told you that include external IP for ICB. If there is a net device, assume there we are using a net device, simply net device will change the source. For example, this is here 101.1.100. Suppose there is any net device, what a net device works, net device will change. For example, this is change, we are using, assume it is A, and we will translate into B. So when change was done, that was A. When verification was done, then the source was okay. We know net device always change the source. Okay, when verification, when we create hash products, then source was A, this is A. But now when the packet will pass through the net device, what it will do, it will translate A into B. So when they will verify, yes, the net device will change the source IP address. Okay, now source is B, so hash will never match. Okay, if it there is a net device, because AH include external IP for ICV. If there is a net device will change the source IP address in the external IP header. When the receiver will receive, that will receive an external IP header with a change source. When it will verify, then always source will not match. So here we can say AH doesn't work with net.